Hi, Zalalam here from 2620 Isaac YouTube. Today we will discuss Java data types and arrays. But first, if you like my video, please comment and share. And don't forget to subscribe my channel. So, what are data types in Java? What's a data type? Data type is classification of data so that it determines what type of value or what type of variable we can have to that data type, and it also determines what type of operation we can apply to it, and it also shows us or indicates us how that data type is going to be represented in memory, or how it's going to be stored in memory will be determined by data types. So it's very critical that we understand what data types are. There are two two types of data types in Java. The predefined ones, or they are mostly called predefined, but this is not specific. Primitive data types is more appropriate. When we say primitive, these are created without the help of any other data type, and they are the basis for the programming language. And the other is user-defined or complex data types, and these are usually created by programmers for various purposes, and usually they are created by combining different primitive data types, and primitive data types are very critical here in defining the complex or user-defined data types. These, as we have discussed, these primitive data types are defined without the help of any other data type, and they are the cornerstone and the backbone of the programming language, and they are atomic. That means they are single, and they cannot be divided into two or more parts. And as we have said, how it is represented in memory and how it's stored in the memory is defined by the data type in Java. For example, the integral type has got 32 bits width in memory, and this is fixed whatever the platform is, and this makes it Java portable so that it will not change the memory presentation and storage characteristics. So the primitive data types, there are 4 primitive data types. Integers, this includes the data types byte, short, int, and long. We will see them in detail in a bit. And the other is floating point numbers. That means numbers with fractions or decimal points are called floating point numbers. And we have got characters. Sometimes they are considered as integers too, as characters are represented in numbers. And the last one is Boolean data type. This is a data type with 2 values, either true or false. And when we say user-defined, we use the syntax of the language and primitive data types to create complex data types. And for example, if we create a type called employee in Java, we will create it like this. So here it says public class employee, so the type is employee. We will discuss about the terms public and class in coming videos, but it tells that we are creating an object called employee. So we will use these data types as we have discussed. We have seen short, which is a type of integer, int, which is a type of integer, and string is a special type in Java. It is not a primitive data type, it is an object type created to work with strings. That means a series of letters, numbers, and other characters. It's not a series of char variables, so the character one, but string is not a series of or an array of character. It is a special type of object that helps us work with strings or manipulate and work with strings. So these are the two types of data in Java, and as we have discussed, employee is now a data type, a user-defined data type, and it has got its semantics, syntax, and access rules that we will study later on when we reach to classes. So what is now we will see the primitive data types in detail, their characteristics and their possible values too. So when we say integers, okay, as we have discussed, integers define mainly the four integral types, and these include byte, short, int, and long, and all are signed. When we say signed, it includes both negative and positive integer numbers, and Java doesn't consider the concept of unsigned integer. As you know, unsigned integer is designed to utilize the higher order bit for sign, that means negative or positive, but Java handles it in another way. We'll discuss it later on. So there is no concept of unsigned integer in Java, and as you can see, byte is an integer with a width of 8 bits. So here you can see that it has got 8 bits, and byte can represent numbers from minus 120 to 127. When we say 8 bits wide, we can handle numbers up to the power of 8 widths on the negative as well as the positive side. And then short data type, which is 16 bits wide, and this can handle numbers from minus 30,700 to positive 30,700. And the other integral type is int, which is 32 bits wide. So this can handle numbers from minus 2 billion up to 2 billion, and long data type is 64 bits wide, and it can handle from minus 9 quintillion to positive 9 quintillion. As you can see, this is a very large, big numbers, and these are the integral data types in Java. The others are floating point data types in Java, and there are two types of floating point data types, the float and double. And as we have discussed, they are used in working with numbers which require fractional precisions, and floating float data type is 32 bits wide, and it can handle from minus 1.4 times 10 to the power of minus 45 to 3.4 times 10 to the power of 38. And the double data type is 64 bits wide, and it handles pretty large numbers, and the difference between the two is the precision after the decimal point is extremely precise with double data type. And these are very important data types in precision number handling. The other is characters, and character data type is defined as char in Java, and this is a Unicode representation of characters, and it is a 16-bit wide data type, and so it can represent characters up to 65,000. So there are no negative characters, so there is no negative number in characters, so we can represent 65,000 characters with the character data type, and as of now it can handle all of the languages available in the world letters in the world. So we will see later on how we can manipulate characters. So a character ranges from 0 to 65,000, and each number has got its own specific characters assigned to it. The other is Booleans. Booleans are data types, and they are defined as Boolean in Java, and it has two values, true or false, and these are usually a result of relational operations. For example, if we have an operation 10 greater than 8, this statement results in a true value, and this Boolean data type is very important in controlling conditional statements. We will study them later on, and loops as well. For while and do while loops are also controlled by Boolean data type. And in summary, the primitive data types are divided into two, Boolean and numerical types. As we have discussed, Boolean has got two data values, true or false, and numerical types have got two types, floating point and integral types. When we say floating point, these are numbers with fractions or decimal points, and they include float data type and double data type. As we have discussed, float is 32 bits wide and double is 64 bits wide, and integral types include long, int, short, byte, and char. We have included character here as integer. As we have discussed, it is represented in numbers, so it can be considered as integral type. So these are basic primitive data types in Java, and they are very critical backbone of the Java programming language. So to utilize data types in the programming, we need identifiers. This is a technical term for naming of data types or defining variables using data types. So identifier is a name for a variable or a function as well. So we use a sequence of letters and digits from characters, um, and we combine them to create an identifier, and it includes letters from A to Z, capital or small, and numbers from 0 to 9, an underscore, and a dollar sign. These are all considered as letters for um, identifiers, and whenever we create identifier, we can start only with a letter. That means the capital or the small A to Z, or an underscore, or a dollar sign. We cannot start an identifier with a number, and an identifier cannot have a space in between words. If we are using two or more words for identifier, we cannot have a space in between. Um, uh, we can use identifiers very simple, like for example we can name data type hello world, um, and this will be tied to the variable that we have created, and we usually need qualified identifiers or names for like packages in Java. We will discuss what packages are in Java, and usually they are separated with a period or dot. Um, so we can use simple or qualified names. We can qualify names of variables too, but it's advised that they can be, or that it's advised that they be simple and meaningful as well. And So, as we have discussed, identifier is a technical term for a name for a variable, and we give these identifiers to methods or functions, variables, packages, or class. We will discuss what classes are in Java, but once they are created as class, as we have created previously the user-defined data type employee, we can define a variable of employee or an identifier of employee, so that we can use it as store it in memory and use it as well in the programming. There are very important identifier gotchas that you have to consider critically. One, the identifiers are case sensitive. That means this, for example, these all are termed hello world, but there is a difference in spelling. So this hello world identifier and this hello world identifier, this one and this one, are totally different identifiers in Java. So if we define four variables or identifiers with these letters, these are treated differently. They are not the same. So it's very important that we understand this characteristic of identifiers, and always it's advised to create meaningful identifiers. Okay, so if we want to define an age, so an age is a number with no fractional points, so we um, prefer to use integer data types. So the we can call it X. The programming language or the compilers do not mind if we call it X, but when we come back to look into our program, it will be very difficult to understand what we are representing with the value of X. So it's better to define it as age. So if we call the identifier age, it tells us that we are defining a variable for representing age. So if we define a variable as first name, it tells us that we are representing the identifier or variable for a first name. So to have meaningful names or identifiers is very advised. And the other is we cannot use keywords as identifiers. Keywords are words included in the programming language and has got meaning in the programming language. For example, the word int is a word representing the data type integer, and we cannot use an identifier called int, and we cannot use an identifier called boolean. So we cannot use keywords in as an identifier. Actually, the compiler will not accept us, but if we are creating our programs using simple text editors and compile them in a command line, we will have errors, that means at compile time. So it is very important that we avoid using keywords in creating identifiers. So once we understand what data types are and how we create identifiers, so now we will discuss variables. So what is a variable? Variable is a basic unit of storage in a Java program. That means this is a concept where we store data types in the memory, and Java is strongly typed. That means all variables must be declared before they are used. So we have to declare the variable before we use it for manipulating or working on it. So we define variables by mentioning the data type first. That means, is it integer, is it floating, is it character, and so on. If it's so, we will define the data type, then we will follow that one by an identifier, and we can stop there, or we can include the optional initialization. Initialization means giving it a value, the variable a value. So here is the general variable creating syntax in Java programming. When we say type here, it means the data type. That means, is it int, is it short, is it float, is it boolean? So we define it here. And if it's user defined, for example, the one that we have done in our example before, employee, we have to define that data type. Then we provide them identifier. We have discussed how to create an identifier, so we give it an identifier name, and then we can end with a semicolon here. We missed the semicolon here. At the end of any Java statement, we end it by a semicolon. So here the angled bracket shows these are optional parts of variable definition. So we can include equal to value. That means if we define a data type of int and call it age, so we provide it with a value. For example, if the age is 30, we provide it the number 30. It's called literal. We will discuss it later on. And we can also have this comma separated identifier, and optional value is we can define multiple variables in one line. So if we provide type identifier value comma and then another identifier, this type definition applies to this identifier, and we can assign a value here as well. So that's how we define variables. And initialization can be literals or valid dynamic expression. When we say literal a value, a number, as we have discussed, like 30 for an integer, or if it is a string data type, the value could be a name in double quotation. And when we say dynamic expression, it is a valid expression where it can result in a value. For example, if we have variables defined before the current definition of variable, and we want the square of that variable as the value of the new variable that we have defined. Okay, so for example, if we have a variable called a, and we define a variable called b, and if we want b to be the square of a, we can assign the value of b to be a squared. So that will be a valid initializer. The other important thing about variables is variables are scoped in Java. That means variables defined are visible in the scope they are defined. For example, if we define a variable within a method, that variable is accessible only within that method. If we are defining a variable within an if block, that's accessible only in that block, and they can have block scope or access in variable definition of Java. We we can access the variables in their definition scope. And the other important thing is if we have, for example, variables defined with the same name at inner scope and outer scope, we will see in NetBeans what we mean by inner scope and outer scope, and if they cannot have similar names, otherwise there will be conflicting access to those variables, and the compiler will have difficulty identifying which one are we mentioning in the expressions. And a new concept from JDK10 is that we can use the keyword var to define an identifier, and the type or the data type of the that identifier will be inferred from the initialization. So always var variables must be initialized, and we can use that one in a scope block, for example, in a method. We will see what we mean by in the other important concept in data types is converting between data types. If we have byte data type, can we convert it to int data type? Can we convert a long data type to int data type? That's what we mean by type conversion, and technically it's called typecasting. So it means assigning the value of one type to another, and there are two ways of converting. One is automatic. Sometimes one data type is promoted to another one based on the expression we are applying, and the other is by forcing it or coercing it with conversion. So when we say automatic conversion, the two types must be compatible, and the destination must be larger than the source. For example, we can have automatic promotion of the int data type to the long data type. We cannot have automatic promotion of long to int. We have to force it, because long is 64 bits wide and int is 32 bits wide. So if we force it, we will lose the some of the datas in a long data type, and we will force it to int. Otherwise we cannot have automatic promotion. And when we want to cast incompatible types, we have to mention the type of the data type to be converted to into brackets, and then we follow by the source type. For example, if we want to change long to int, we have to put int here, and then we put the identifier of the long here. So the in with some rules, Java also does some automatic type promotion in some cases of expression. For example, if we assign or initialize a value to a double data type, where one of the types is int type and the other one is double type, then the initializer int type will be automatically promoted to a double type. So that is without our intervention, the compiler will promote one data type to other one, and it has got specific rules that has to be applied or kept to have valid type conversion. The other important data type in Java is arrays. Arrays are a group of similar data types identified by one identifier, and this is very important concept to have a variable of one with multiple values, and this arrays can be one dimensional, that means it's one dimension, or two dimensional. If we want to represent a matrix, we will have two-dimensional arrays, and we can have more than two-dimensional arrays too. So to define arrays, we use the type followed by angle brackets, and then we provide the identifier. Or we can have the type, identifier, and finally we have the angle brackets. This will define the array data types, and we can initialize during defining the array, or we can initialize it with later on after definition. So as you can see here, it says new type and size. We can define it, initialize it like that. And when we say new, it's a keyword in Java to create a memory for a specific data type, and size is the number of items that should be included in this array. So once defined, each member of the array can be accessed using indices, and there the indices of an array starts from 0. So if we have array with a size of 8, our indices will start from 0, and the last item will be indexed 7. So these all include 8 items. Next video we will go into our IDE and work with data types and their behaviors. That's it for this video. Thank you for your time.